want to look at more congruence criteria. So there are 6 possible ways to look at congruence. Here are all the 6 possible ways to combine angles and sides. We've already shown SAS is true, ASA and SSS. So now we want to look at these other 3. This one, this AAA, is not true. Essentially, if I look at any triangle, so here's a triangle, we can copy this and paste another one, and we can grow it. Well, all of our angles are still the same. This angle matches this one. This one was a right angle in both of them. And this angle will match this one. So this one is not true. So that gets us down to these 2, AAS and SSA. So now let's take a look at those and see if we can figure out whether or not those are true. AAS states that if 2 angles and any sides of one triangle are congruent respectively to the corresponding 2 angles and side of the second triangle, then these triangles are congruent. Here are 2 triangles. We know that these 2 angles are congruent. A is congruent to X and B is congruent to Y, and then we just need any other side to be congruent. If AB was congruent to XY, then we would have angle side angle. So we're going to instead assume that side BC is congruent to side YZ and try to get this congruence criteria. If we scroll down a little bit, we know that if angle C and angle Z are congruent, then these are definitely congruent by angle side angle. So instead, I'm going to assume that these 2 angles that are left are not the same. And I'm going to go ahead and assume that C is the bigger of the 2. If it's not, just change the lettering and so that it is. We then want to construct this angle DBC that's congruent to angle C, angle Z, such that D is between A and B. So essentially, I'm constructing this edge so that these third angles are congruent. By angle side angle, this triangle DBC would be congruent to XYZ. This means that this angle BDC up here needs to be congruent to angle X since they're congruent triangles, but that's also congruent to angle A because that was part of our assumptions. However, the exterior angle inequality says if I look at this little small triangle up here that I'm going to highlight, this little tiny one here, this angle BDC is an exterior angle, so it should be greater than angle A, the interior angle. But it's not, it's equal, so that's a contradiction. The only thing we assumed was that angle C was greater than angle Z. So it can't be the case that this is true. If angle C is smaller, then this proof is almost identical. Instead, we just draw the ray in this triangle over here and we get the same issue. Therefore, we must have that these angles are equal, which means they're congruent. Going back to our list of possible congruence criteria, we've now proved AAS, and we're only left with this SSA. SSA is not quite true. It's not quite a congruence criterion, but it's pretty close. If I have 2 triangles ABC and XYZ, and I went ahead and drew these not congruent down here, and then I know that AB is congruent to XY, I know that AC is congruent to XZ, and I know that angle B and angle Y are congruent. Then either C, this angle here, and X are supplementary, or my triangles are congruent. So this one actually is going to have 2 cases. Either they're congruent, or these 2 angles here will be supplementary. So let's scroll down a little bit and look at proving this. We start by supposing BC is not equal to YZ. If it is equal, then we have side, 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 and these triangles are already congruent. And we'll assume side BC is the longer of the two. I'm then going to construct this point D on my segment BC such that side BD is congruent to side YZ. Then if I look at this triangle ABD here, I have the sides, the angles, and the sides are congruent, so by side, angle, side, this triangle ABD is congruent to XYZ. Since these triangles are congruent, the third sides have to match, so AD is the same as XZ, and we assumed that XZ was the same as AC to start with. This means that this triangle here, ADC, has to be isosceles since it has two congruent sides. That means the measure of angle C has to be equal to the measure of angle ADC by isosceles triangles. That needs to be equal to 180 minus ADB, since ADB and ADC are supplementary angles, which has to be equal to 180 minus the measure of angle Z, since ADC has to be equivalent to the measure of angle Z because of my congruent triangles. And I realized I made a mistake in the statement of this theorem. It's not angle C and angle X that are supplementary, but instead angle C and angle Z. Sorry about that. And so I can get that these two angles are supplementary, which is exactly what I claimed now that I have fixed the statement of this theorem. So it's not quite a congruence criterion, but it is really close. And so now I have this one, which is a kind of, so I'll go ahead and check it off, even though it's only really kind of a congruence criterion since we do have this other extra case.